Hi there. In this tutorial, we're going to be going over how to use the open source text-to-image AI Stable Diffusion using Python. This will enable you to do a lot more than just generate out simple images, and I'm going to be walking you through the entire installation process. Now, don't worry if this seems a little daunting. You don't have to have any previous programming knowledge to follow this tutorial. Without any further ado, let's get into it. Alright, so before we get into all the crazy image generating AI stuff, we first have to install a couple things to get our system set up. So the first piece of software we need to download is something called Git. It's provided by GitHub, and it just allows us to manage downloads of large data sets or open source repositories. In our case, we're going to be downloading the Stable Diffusion repository, which has a lot of data. It's almost 32 gigabytes in size, so we need something that can handle that. Now, all of these download links you can find in the description down below. We're just going to be clicking this link right here, and that'll start the download for Git. Now, I'm currently using Windows, so if you're using Linux, you might have a different setup. If you're using macOS, I'm sorry to say this won't work because you need a dedicated GPU for this. So now that Git's installed, we can just double click on it. After we give Git access to install on our Windows machine, we can then click next a bunch of times. We got to do this quite a lot. All right, there we go. Now it's installing. Once that's all set up and installed, we can just say finish. All right, so the next piece of software we're gonna be installing is called Python. And to do that, we're gonna head over to python.org/downloads/Windows. And this link will be in the description, but we can just Control F here and search for Python version 3.9. So that's the very specific version that we're gonna be using today. And it is required because this next piece of software that we need to install here called PyTorch only works with Python 3.9. So that's the version that we have to install. So if we scroll down here, there are quite a few versions, and we're actually looking for a Windows installer. So you might see these other versions here that don't have the Windows installer, but what we want is something like this, where it has the download Windows 64-bit installer right here. So we can just click that, and that will download a python.exe file. Let's double click on that and open that up. So once this screen pops up, we're gonna check this little add Python 3.92 path. This is very important. Now we can just click install now, and it should start installing Python. All right, so now that Python is successfully installed, we can close this, and then we're going to head over to this huggingface.co website. Now, huggingface.co is a website that hosts a lot of open source AI models, and they're actually the ones that host Stable Diffusion and published it. So if we go here, we can search up Stable Diffusion, and we can go to Stable Diffusion version 1.5, and we click that, and this is actually the full Stable Diffusion model that we can install and download. Now we need to actually read and accept the license before we can download and install it. So we need to sign up or log into our account, which is really easy to do. You can just click sign up. Once you've created an account and logged in, you can then go up here to the search bar and search for Stable Diffusion. And we can find the Stable Diffusion version 1-5. Now there should be some kind of license agreement that looks something like this, like agree and access repository. So just click that, and then you'll be able to actually download the repository. So in order to actually download this, we can click the use in diffusers button right there. And then we're going to copy this and just paste that into our command prompt. So let me walk you through what each of these commands is line by line. This installs the Git large file storage service, and this will allow us to install really large files. So because Stable Diffusion is 32 gigabytes in size right now, it needs a special type of software to get this on our computer. This next line here just clones the actual repository itself. And this third one here just does some behind the scenes stuff. We don't really need to worry about that. So we can just copy all of this, or just click the button right there, open up command prompt here, and then just paste that right in there. So it's warning us here just because we're copying and pasting multiple lines, but that's okay. So let's do that. And now it should start actually installing the Stable Diffusion model. So this installation will actually take quite a bit of time, and just to give you a heads up, this command prompt will not actually show any progress that's being made on the download. And to check to see if it's actually still downloading and it hasn't crashed, you can simply pull up the task manager here and just take a look at the Ethernet. And as we can see, it's currently downloading and there's a lot of activity right there. So just keep an eye on that, wait for it to download. It typically takes about 10 to 30 minutes depending on your Wi-Fi connection, but it might differ depending on your Wi-Fi and your provider. All right, and once it's downloaded, the command prompt should look something like this. It'll be in its idle state with the cursor blinking there. And you're probably now wondering where it downloaded. So we can actually see it right in front of us. It's just this directory right here. It's in our C drive under users and Torrin. My full name's Torrin. I don't know why Windows decides to shorten my name like that for some reason, but we can go to the C drive right here. Then we can go to users, Torrin, and we scroll down and we'll see Stable Diffusion version 1-5. And we open that there and we can see everything right there. So let's go back And I want to show you guys something. So if we right click on this, click on properties, then view the actual size of this, it's actually gone up quite a bit since I last installed it, and it's about 32 gigabytes. So that's a really big file. I'm going to show you guys a little trick to reduce this size. So if we click OK, we go here, we select this hidden file, and you might need to enable seeing hidden files, and we can do that by going to options of the file explorer there. Then go to view, then we go to hidden files and folders, and we show hidden files and folders and drives, and click OK. Then we can select this .git file there and just simply delete it. And what that does, if we go back here, it will remove quite a large amount of that folder size. And if we click the properties again and view the folder size, it should just be 16 gigabytes. So at first you will have to actually install the full 32 gigabytes. I know it's kind of annoying and pointless, but it's just an artifact left over from GitHub. With that being said, let's move on. It's kind of boring. I just thought you guys might want to know. So the next thing we need to install is something called PyTorch. Now, PyTorch is a Python module that allows you to create AI models and also use them and manipulate them. So it's really crucial for what we're doing. So I'm just going to head over here to pytorch.org, click install. Then we're going to scroll down. We're going to click pip, this little button right here. Then we're also going to click CUDA 11.7. Then we're going to copy this right here. We're going to open up our command prompt again, and then just paste that command right in there. So after that's done, we can just click enter, and Torch should be installing right now. Now, while that's going, I want to explain a bit about what this version is right here. We're actually installing a very specific version of PyTorch that runs on GPUs, since we're asking for that CUDA 11.7, which is just a software that allows other software to interact with GPUs directly. And as we can see, it's installing here, so it's 2.3 gigabytes in size, so it's going to take a little bit of time to download. Now, another thing to note, if you just install Python 3.11, you're going to get an error here in the download for PyTorch, and that's because you didn't install Python 3.9, which is the one that we need right there. So Python 3.9 is the latest supported version of Python that PyTorch offers. I know all this version stuff is very confusing, but install Python 3.9 right here, and then PyTorch should install just fine. Trust me, I've experienced that error myself, but it's really simple. You just install the wrong version of Python. And after a successful installation, you should see something similar to this. Like I mentioned before, if you ran into an issue, it's most likely your Python version, so go back, uninstall any previous version of Python, and then make sure you've installed the Python 3.9 version. All right, so moving on. The next thing we actually have to install is back here at the huggingface.co Stable Diffusion version 1.5 page. And we can see here that it requires the Python library Diffusers. So if we click this link right here, it'll take us to the GitHub Diffusers repository. And if we scroll down, we can copy this command right here that says pip install -- upgrade diffusers torch. We can go back to our command prompt here, paste that in, and install that. So Diffusers is just a Python module that allows us to interact with Stable Diffusion and PyTorch itself using very simple Python code. So after that's installed, we can just close out of that. All right, so one final thing we have to install, I just remembered, is this module here called Transformers. Now, Diffusers, the module we just installed, is based off of this module, so it should have installed Transformers properly when we installed Diffusers. But just to be safe, we're going to install it here, because every time I've done it in the past, I always ended up getting errors if I didn't do it like this. So we're just going to scroll down here, and this link will also be in the description. We're going to go down here, and we're going to look for the pip install command here, which looks like right here. So pip install transformers. This is just a command prompt here, and we're going to put that in there, and that should work. There we go. Everything's good. Moving on, and basically we're all set to start coding. Now, if you want to get fancy, you can install a Python integrated developer environment such as PyCharm or VS Code. So I use PyCharm, and you can find that just by searching up PyCharm and go to the first link right there, click download, and then just download the community version. Don't worry about the professional version. It's just JetBrains trying to get money out of you. All right, so I'm back here on my desktop. Now let's go ahead and open up that PyCharm program we installed. This is gonna allow us to program in Python a little bit easier than just with a text editor. So if you want a more detailed tutorial on how to use this program, I suggest checking out my previous Python tutorial, because I go into a bit more depth on the installation and how to set it up. But in short, for what we're doing right now, we're just gonna open it up and click new project right there. We're going to name this project Stable Diffusion Tutorial, like that. And then we're gonna check this little box right there that says inherit global site packages. This is going to allow our project to see the packages that we just installed. So the PyTorch, the diffusers, and the transformers modules. Next, we're going to double check and make sure that this base interpreter here is set to Python 3.9. If you have other versions of Python installed in your system, you might have conflicting versions that will affect the program, and we don't really want that. So we're just going to keep that as Python 3.9, and that's it. We can just create the project. So let's go down there. We're going to click create, and we'll be presented with this main.py file that just has some boilerplate code. We can just get rid of all that, close the notifications, and on the left side here we can see that this is the main.py file that we're working in. There's also this folder here called env. We don't really need to worry about that. That's just the environment that we're working in right now. To get started, what we're going to be doing is importing a couple modules. So we're going to be importing first the OS module, and this module allows us to interact with the operating system, so we can create folders, delete folders, create files, delete files, and a whole bunch of other things as well. It's really useful. The next module we're going to be importing is something called AutoCast, and we're going to be importing that from the Torch module that we downloaded on our machine earlier. So we're going to be saying from Torch import AutoCast. It should pop up right there. There we go. The next one is from the diffusers. So this is actually the Stable Diffusion pipeline. So let's say from diffusers import Stable Diffusion pipeline. It should be the first one to pop up right there. The next thing we're going to do, it's a bit complicated, but I'll walk you guys through it. We're going to be creating two variables. The first one is going to be the directory path to the Stable Diffusion model we downloaded earlier from the Hugging Face website. So we're going to call this Stable Diffusion version 5, just so that we keep everything nice and organized. Model path, and I'm capitalizing the full variable here because we're going to be using this variable throughout the entire file, so it's really important that we don't forget where it is, and we're going to be defining this variable in a very special way. So let me just write it out and I'll explain as I go along. So we're going to say equals os.getEnv. We're going to put a string there, and we're going to say stv5 underscore model path, which is the same name as the variable itself here. And what this is doing is telling this OS module to get an environment variable on our system. So on all operating systems, Windows, Mac OS, and Linux, you can create things called environment variables to store information about a system. So we're now requesting this environment variable stv5 model path from Windows itself. Currently, there isn't a model with that name, so we have to create that ourselves. So we can go to the command prompt here, type in set x, the variable name, and then we can also pick up that path that we had to the Stable Diffusion model. So we can just go down there, navigate here, copy that right there. Then we're just going to say space, paste that in, and there we go. We've created that environment variable. It's really, really simple. What we've done there, just to recap, we've set the name of the environment variable here and then the value. So that value can be anything. We just so happen to be using a directory path here, but it's a really useful thing that we can do. So we can close this out now. Now we're going to create a second variable. Now this is going to be the save path where all our images are going to end up. So we're going to call this save path, just like that. Then we're going to set this to something a bit complicated, so I'll walk you guys through what we're doing here. So we're going to say os.environ. We're going to index this list for a value called user profile. I think I'm spelling that right. And what this is getting is actually that folder that we found the Stable Diffusion model in. So as you can see, there's this user right here, the drive letter, users, and then it'll get this Torrin directory right there. And that's the main directory for my user on this machine. But we're not finished just yet. We want to actually store these images in a place that we can easily access. So like the desktop, for example, I think that'd be a good place to store all these images. And we can do that by just typing the following. So we do comma, quote, desktop, like that. Next, we specify the folder name that we want these images to be in. So we're going to say SD output. Just like that. We're going to add some parentheses around this whole statement here for this variable, and then we're going to say os.path.join to join all of these strings as a singular directory. Next, we're going to create an if statement just to verify that this directory works. So we're going to say if not os.path.exists parentheses save path. This is going to check to make sure that that save path exists before proceeding with the program. If the path doesn't exist, it's going to create a directory with os.makedir. And we're just going to pass that save path into there like that. So every time this program is run, it'll first check that that save path directory is made so that it actually has a place to store the images. Now, when we're rendering out a lot of images with the software, we don't want to be writing over the previous images, right? We want to save and store all those images so we can show our friends, show the internet, and so on. So it'd be really useful if the software didn't overwrite those images. So what we're going to do next is create a little function that will make the file names for each image that's generated unique to that image. So let me show you how we're going to do that. Let's create a function. We're going to call this function uniqueify. I think I spelled that right. we're going to pass in a path variable to this function. So this will actually be the path of the image itself. Next, we're going to create two variables. So we're going to call one file name, comma, and then extensions. So we're grabbing both the file name of this path and the extension of it. And we're going to get that by going os.path.split text. And we're just going to simply pass in that path variable there. Next, we're going to add a counter. So we're going to use this in a second with this while loop here. We're going to say while os.path.exists. We're going to pass in that path there. So while that path exists, we're going to say path equals file name. And we're just going to modify this file name so that it has a unique character for each iteration of the image. So if the image has the same prompt name, we're going to increment the file name by an integer. So you'll see what I mean by that in a minute. It sounds scary, but it is quite simple. So we're just going to be adding some parentheses here. So this is what is actually going to be appearing in the file name. So we're going to also add a string right here. We're going to add that counter, which is how we're going to increment the file name itself. Then we're going to add another string right here, and we're going to just close that parenthesis so it looks all nice. Then we're going to add the extension right there, just like that. And we're going to increment that counter just that each file name in this loop has a new unique file name every time the loop is gone through. So we're going to say counter. We're just going to increment that like so using plus equals 1. So that'll increment it once every loop. The next line is pretty simple. We're just going to return the path value. So once this while loop is broken, that means that the path itself is unique, meaning that the system found a unique image that wasn't actually taken up. So it'll guarantee that we will have an image generated with a unique file name. So we won't be writing over any of the previous files we've already created, which is nice. Next, we're going to create the prompt. So this is just simply going to be some text that we add in here. Let's just say a dog riding a bike for now. We're going to add some spacing there just so it all looks nice. And we're going to verify that this prompt is actually within a certain character limit, because Stable Diffusion doesn't really like really long character inputs. So we need to make sure that we're under a character input so that it can create the best images possible. How we're going to do this is pretty simple. We're just going to create a print statement here. We're going to create an F string. F strings are really cool. You can create a string out of multiple types of data very easily, and I'll show you guys how to do that. So we really just want to print out how many characters there are. So let's just say characters in prompt. And then we're going to add some curly braces here, and then we're going to get the length of that prompt, and that'll print out an integer that is equal to the number of characters within this string here. And then let's create a limit here just so we can visualize it. So limit, let's set the limit to 200 characters, and that should print out some useful information. The next thing we're going to do is create the pipeline for Stable Diffusion itself. So we can do this just by creating a variable called pipe. We're going to set this equal to the Stable Diffusion pipeline we imported up here. From there, we're going to go dot from pre-trained, and all we have to do is just pass in this model path right there, and we can just put it there and we're all set. So the next thing we have to do is then activate this pipeline on the device that you want to use. So we can just say pipe equals pipe.to, and then we're going to specify if we want CUDA or CPU compute. Now my computer has 2 graphics cards, so what I'm going to do is just set this to CUDA. If you have a CPU based system, you're going to want to set this to CPU there. And I just want to add that you also should have installed the PyTorch library with the compute platform set to CPU right there. So you will have to install that separately, just a note. Next, we're going to actually call this pipeline. So we're going to say with AutoCast, that function we imported up here. We're going to set this to CUDA as well. I forgot to switch this back to CUDA up here. So this will render out on my graphics cards. Then we're going to actually create an image. So image equals pipe prompt. So we're passing in the prompt there to the Stable Diffusion pipeline. Then we're going to go dot images, and we're going to get the first image out of there by just setting that to 0. Then we actually have to create the image path. So we're going to do that by creating another variable. We're going to say image path equals to that uniquify function that we created. We're going to set this to os.path.join. In here, we're going to pass in that save path as well as the prompt, and we're going to do something a little tricky with the prompt here. We're going to say prompt. We're going to set this to the 25th character, and then what we're going to do is add a parentheses here just so that we can indicate when we've gone over this 25th character limit, so that we can include the prompt in our file name so we know what prompt was used for each image. But we don't want the prompt to be super long for the file name because we can get to all sorts of issues with directories. To get around that, we're going to say if the length of the prompt itself is greater than 25 characters, reduce the length of the prompt and include parentheses, else include the prompt in the full file name. And then after this, we're simply just going to add back in the .png extension there. So from here, we can then just print that image path out, just that we know where the image is actually stored. And then we're just going to simply save the image by going image.save and then the image path down there. Now I did make one mistake. You got to go back here and change this from image to images with an S. So just keep that in mind. And we're done. That's it. You're all set to go. So all we actually have to do to run this program is simply go up here to this little green play button and just press play. So after you press play, it should look something like this over here. You'll see this red error message right here, and it's saying something about FTFY or Spacey is not installed using BERT. Just ignore that. It always works, even though that error appears. But you'll see this progress bar appear down here, and it'll slowly tick up with the number of iterations that it's done. And then finally, this directory will print out that will tell you where the image was stored. So if we open that up here, and we go to the File Explorer and just paste that in, it should pull up an image of a weird looking dog riding a bicycle. And that's it. We've basically just generated a Stable Diffusion image on our computer using Python. How cool is that? So this is all really cool stuff, and I cannot wait to see what you guys create with it. I really hope that you guys learned a lot in this video and found it very helpful. There's a lot that I cut out of it, and I can go on and on and on about other ways that you can customize it. But let me know in the comments down below if you'd be interested in seeing a part 2 to this video where we further customize the prompt engineering and create even crazier algorithms for it. I'd love to hear what you guys have to think about it. Oh, and by the way, I forgot to mention a big thank you to the people who commented on the previous videos about the audio being off sync. I think I fixed it. Let me know if it's the case. I think it was like 200 milliseconds off for some reason with OBS. So thank you for pointing that out. I really appreciate all the help. Please keep sending me more feedback of how I can improve all this stuff. I'm really trying to build something here. So thank you for all your comments. Anyway, that's it for now. Thank you for watching and see you in the next one.